This is an epic binomial expansion question. Not only do we have a and n that we don't know, and we'll have to figure them out, we've got the expansion, but we're also timesing it by 1 minus x. All right, well, all we can do really is find the first few terms of the 1 plus ax to the n and go from there. So here's the binomial expansion formula. Notice that, well, the a's are not the same. This is like our first term, so that is going to be 1 in this case, and the b is going to be ax. So I'll forget about the 1 minus x. 1 plus ax to the n is going to be 1 to the n, which is actually just 1. 1 to any power is just 1, plus n choose 1. We'll come back to that in a minute. Times 1 to the n minus 1. That's just 1 times b, which is ax. Plus n choose 2. 1 to the n minus 2 times b squared, so ax squared. All right, and then it's going to continue, but because we've just got the first three terms, I'm not interested in the cubic, just finding those, up to the quadratic. Right, there's some simplifying to do. So n choose 1. It's worth actually knowing this. It's going to be n. It's always n. It's like when you have Pascal's triangle, it's this one here, and it always just kind of keeps increasing. So 20 choose 1 is 20, for example. But let's show where this comes from using the choose formula. So it's going to be n factorial divided by n minus 1 factorial, and then it's going to be 1 factorial there. Now this is going to cancel down because n factorial, in fact, I'm going to do another line for it. N factorial is actually n times n minus 1 factorial. I write it like that because then I can just cancel these out. And then n choose 2. A little bit more complicated again. I'm going to get a squared x squared. So this time I'm going to get n times n minus 1 times n minus 2 factorial. And it's going to be these two that cancel out. And I've still got my a squared x squared there. So finally, taking a bit of work, but it's going to be 1 plus n ax plus n minus 1 over 2 a squared x squared. Okay, that's probably the trickiest part of the question to be able to get to there. So now we can write down that 1 minus x multiplied by this 1 plus n ax plus n minus 1 over 2 a squared x squared is equal to 1 plus 23x plus 228 x squared. So I can see the only way I'm going to get 1 is by timesing those ones together. Let's look at the coefficients of the x term. So to get 23x, I'm just going to write the coefficient now though, it's going to be by doing 1 times nax or by doing minus x times 1. So that is my coefficient of x. The left-hand side is the 23x here on the right-hand side of the above equation. And then the right-hand side is how I can get x from multiplying it out. I can't get it any other way. I'm doing x times a constant term and then 1 times a constant term. So I've got that NA is going to be 24. I'll just leave that there for the moment. And let's deal with the x squared term. I'll do this bit in green. Okay, so now I've got 228, and that's going to equal 1 times n minus 1 over 2a squared. That's my x squared coefficient from there. Or I can get it by doing minus x times nax. So minus na. And I've got simultaneous equations. I'm just going to put a little box around them. Na is equal to 24. And then this one here as well. So first thing I'm actually going to do is replace this NA by 24. Just substitute the whole thing in and then add it onto both sides because that will leave me n minus 1 over 2a squared is equal to 28 plus 24, which is 252. I'm going to also multiply through by 2. That'll give me 504. All right, time to sub in for one of n or a. Now the n looks a little bit, I mean, I know it's a squared on the a, but at least it's just like one single thing, whereas I've got an n and an n minus 1. So I'm going to make a the subject of this equation. A equals 24 over n. So sub that in, n minus 1 times 24 squared over n squared is going to equal 504. We're getting there. The n and that squared are going to cancel. I'm going to work out what 24 squared is. 576. So 576 times n minus 1 is going to equal 504n. That's up to you. You could either cancel it down at this point, or we could just go for it. I think I'm just going to go for it and expand the bracket, then minus the 504n and add the 576 onto both sides. Probably easiest to do this. So 72n is going to be 576. I'm expecting a whole number for n. We know it has to be 576 divided by 72 gives me 8. Nice one. Actually, I'm there because remember a is equal to 24 over n. So I can just put that back in. A is going to be 24 over 8 or 3. So it all comes out really nicely in the end. Quite challenging, I think, but let's just recap. I've done an expansion of 1 plus ax to the n. The first three terms, they're the only ones that are going to be important. The trickiest bit, I think, of the whole question is to be able to rewrite it like this. Hopefully you've seen it before. If not, that's going to be tough. But yeah, they cancel out. This is why it's so important to not just always stick things in your calculator when you're dealing with factorials, like 5c3, but think about how you can get it without a calculator. In this case, it'd be 5 factorial over 3 factorial, 2 factorial, 5 times 4 times 3 factorial over 3 factorial, 2 factorial. The 3 factorials cancel. I do 20 divided by 2, I get 10. So we've done that algebraically. We actually get just n. nc1 is always n, and then we get n times n minus 1 over 2 for the other one. We've dealt with the the multiplying out of the brackets, equated the coefficients, got two simultaneous equations, substituted in for the NA, made another more simple equation, substituted in for A, worked our way through it to calculate A, put it back into the other one to give, sorry, I worked out N and then put it back in to get A after that. All right, good effort on this question. I hope it makes sense. Well done.